Welcome, everyone. We are happy to have you here at Notes 2020. I'm Marpella from Data Science DC. We are a community of passionate enthusiasts in all data science topics related. For example, data visualization, data education, data wrangling, and so on and so on. Our umbrella community is Data Community DC, and overall, we are a 10,000 group members. We are so happy to participate today. I would like to introduce our speakers for today, Andrea Santurbano and David Allen. They will be presenting on Create a Graph Data Pipeline with Apache Spark and Neo4j. Andrea Santurbano is CTO at Laris Business Automation. With 7 years of experience in developing high-performance, mission-critical systems and large-scale data pipelines across multiple and heterogeneous systems. Andrea loves open source and contributed to several big data projects, such as Apache Sapling, Cypher for Apache Spark, and other for the Neo4j ecosystem. As a developer, he is very curious about discovering new technologies and enjoys the continuous learning process that allows making things better every day. David, on the other hand, is a deeply technical generalist, bringing his experience in managing teams and driving towards complex goals to Neo4j's partner organization. The most fun he has had in his career is when he's learning something new or trying to figure out how to do something that hasn't been done before. Thank you both and welcome.
Good evening to everyone, and thanks to be here to create a graph data pipeline with Spark and Zeppelin session. I hope that wherever you are safe and healthy. So let's go to the hot stuff. Who are we? I'm Andrea Santurbano. I'm CTO at Laros Business Automation, which is a Neo4j Italian premier partner. And we in Laros love a lot Neo4j. We love a lot the technology. So let's talk about Laros briefly. So the company was founded in 2004 by our CEO, Lorenzo Speranzoni, and we have offices in Pescara, Rome, and Milan. We are a data-driven company that help the companies to become insight-driven organization, and our specialties are build big data platforms, data engineering, graph data visualization, machine learning, and AI, and other data-driven stuff. So our graph story with Neo4j, our love story with Neo4j is quite ancient. It became in 2011 when our CEO Lorenzo met Jim Weber, the chief scientist of Neo4j, and they start to talk about this new kind of technology that can help to extracting insights from the data. So Lorenzo started to play with Neo4j, and in 2014 we became the first Italian solution partner of Neo4j. The next year, in 2015, we had the first Italian certified professionals. And in 2016, we created the official Neo4j JDBC driver. In 2018, we created a lot of epoch procedure. We are now, I think, about 200. We developed more 200 epoch procedures. We also created the ATL tool. We contributed to the GraphQL Neo4j plugin. We are the creators of the Zeppelin integration for Neo4j. And the last year, we built the official Neo4j Kafka connector. And this year, we are working with Neo4j in order to develop the official Neo4j Spark connector. And we will unveil here at Nodes, my CEO will unveil our Fist AI solution based on Neo4j, built in collaboration with Fujitsu Labs. So let's give a quick look to the agenda. We will talk about the Neo4j connector for Apache Spark, and we will talk about Apache Spark and how we combine these two different technologies. Then we will talk about how we read the data from Neo4j into Spark, and we have a demo. And then we will talk about how we write data from Spark to Neo4j. And we have two demos, one with simple code snippets, and the second one we will show how to create a simple graph data pipeline with Spark and Neo4j. So all the demo are available at the following GitHub link that is public available. So please download the code and open any issue if you have questions. So what is the Neo4j connector for Apache Spark? In order to do that, we have to step back and understand what is Apache Spark. It's a general purpose distributed data processing framework that is built on top of three main capabilities. It's oriented around data frame and data sets, which are basically tables. We have two kinds of tables, static and streaming. In the last kind of tables, the data is continuously appended to the table. Given the fact that it's a distributed data processing engine, the tables are partitioned, so each node into a Spark cluster has a partition of the table. And the third, but not the last important thing is that is polyglot. So Spark supports 4 programming languages: Scala, Python, Java, and R. So how it's used? It's used in order to build data integration and ETL pipeline, because it can connect via the JDBC data source to any database that supports JDBC. It also can be connected to MongoDB, Elasticsearch, Cassandra, and so on. It can be connected to every stream processing framework like Kafka, Kinesis, Akka, and so on. So in order to collect data from IoT devices, for instance. It's used in order to create interactive custom analytics in combination with notebook runners like Jupyter or Apache Zeppelin. And because it provides a machine learning library, you can do also machine learning and AI with Spark. So how we combined Neo4j and Spark? Our goal is to avoid custom and hacky solution. It's defined by a continuous development, and we try to answer quickly to the issues. There is an official enterprise support given by Neo4j through Larus, and we leverage the data source API in order to be fully Spark compliant. This means that our connector is a polyglot, and you can use it in order to build ETL pipeline or graph-driven machine learning. So how we combine these two kinds of technologies? Because Neo4j is a graph database, and Spark basically leverages tables. Data frame and data sets are tables, as I said before. So we have this concept, tables for labels, where any graph entity is decomposed into tables. So let's think about at the path that we have into the slide. So we have a person that has a job. So we have two nodes, person and job, and one relationship has. So these three graph entities, two nodes and one relationship, get decomposed into three different tables. One for the nodes person, one for the nodes job, and one for the relationship has. This allows us to do a bidirectional mapping in and out from and to Neo4j in a very easy way, as you will see. So let's talk about how we read data from Neo4j into Spark. We allow to read data from Neo4j in three ways. by labels. So you can extract a node by labels, by defining the relationship type, or by providing your custom Cypher query. But let's go deep into it. So you will find here two code snippets just to highlight the fact that we are polyglot. We have the Scala snippet and the Python snippet that basically do the same thing. And as you can see, they are quite similar. So you basically need to leverage from your Spark session, the data frame reader, and then we add the method format. You need to invoke the Neo4j data source, and then you can define the option labels, which contain a concatenated list of labels that you want to extract from Neo4j. In this case, we are extracting all the nodes that are two labels, person and friend. How we read relationship from Neo4j into Spark. Also here we have two code snippets, one in Scala and one in Python. And you can extract the relationship from Neo4j into Spark data frame by using the option relationship, which define the relationship type. And then you need also to define the source and the target labels of the relationship in order to identify a full path. So in this case, in the case of the two-code snippet here in the slide, we are trying to extract from Neo4j the path that we have in the figure at the right of the slide. So we are extracting all the person that directed a movie. How you can, the third way is about querying Neo4j via customer Cypher query. So you can define your read-only Cypher query and define it into the option query, as you can see here into the slide. One important thing when we are reading data from Neo4j into Spark is about partitioning. As I said, Spark is a distributed processing engine. So partitions, tables are partitioned, and partitioning is a very important feature that we leverage. You can leverage a partition by using the partitions option, and as a value the number of partitions that you want. Internally, we use the skip limit mechanism, so the query will be splitted by the skip limit mechanism. We count the data by the options that you defined. For instance, in this case, in the code snippet, we count all the nodes that are person and friend, and then we split that count by the partitions, and each partition by the skip limit get its portion of the data. You can also define a custom query count by using the query.count option. But now let's go through the demo. So let me switch to Zeppelin. All the demo that we have today, we will do them into Zeppelin. Zeppelin, as I said before, is a notebook runner. It's like Jupyter. We will use it because we are the creator of the official integration between Neo4j and Zeppelin. So we can interact with Neo4j directly from Zeppelin in a very easy way. And yeah, we have a bunch of notebooks here. Before you run through the notebooks, please make sure that you run this paragraph. As you can see here, each notebook is composed by several paragraphs. A paragraph is a rectangle like this. You can run a paragraph by clicking on the play button in the upright side, this one. or by typing the Shift-Enter combination on your keyboard. So before run your demo in your local environment, please be sure to run this paragraph that defines all the configuration parameters to Neo4j. So let's go to the first demo from Neo4j to Spark data frame. So in order to show the demo, we will use the Neo4j movie database, which is a quite common database used while we do presentation to who is new to Neo4j. And we basically have this graph structure. So we have two nodes, person and movie, for relationships between them. Yeah, directed, wrote, produced, reviewed, and acted in, and one which is recursive in the data model. It's the follows relationship, but in fact it starts from a person which follows another person. So we need to populate the database. I hid the editor here because we have the big Cypher query that populate our database. So let's populate Neo4j. It takes a few seconds. So is ended, and now let's extract our first data frame. So we want to read nodes as a first iteration. So we have our Spark session here, the data frame reader. We invoke the Neo4j data source. We set the Neo4j URL via the URL option and the out properties, the out type, which is basic, and the username and the password. And then via the option labels, we define the labels that we want to extract. So we are extracting here our only the movies. So then we get the data frame. We filtered it by the movies that have been released after the 2000 included, and we order the data frame by the released and the title column. So let's run it. Okay, as you can see here, we have our columns. So our tables for labels. We have 1, 2, 3, 4, 5 columns. The first two are Neo4j internal information. The ID is the Neo4j internal ID. The labels is the list of the labels attached to the node. Then we have the title, the tagline, and the release properties. So now, this is basically the same code snippet, but written in Python. We are leverage here PySpark in order to have it. Sorry. So in a few moments, the same table should appear. Exactly, we have exactly the same tables as before. I just show you in order to show that our data source is polyglot. Now let's read relationships via Scala. So we have the relationship option here. We are extracting all the directed relationship, and we need to define, in this case, as I said into the slide, the source and the target labels. So we are extracting all the person that directed a movie. Then we filter the data frame by extracting all the person name is source is related to the source node. Here you will find the source that is related to the source node. So we are extracting all the person's name that contains Wachowski in it. So we basically extracting all the movies directed by the Wachowski sisters. So we have here 2, 4, 6, 8, 10, 11 columns. We have the rel-id, which is the internal Neo4j, the rel type, which is the relationship type. The source ID is the internal Neo4j. The source label is the list of the labels attached to the source node. Then we have that all the source node properties are prefixed with the source dot. So we have source name, source board, and basically the same for the target nodes. So we have tag title, tag tagline, and tag released. So here we have the same code snippet, but wrote in Python. We can run it, and we have exactly the same representation. So now I want to show you an option that basically allows you to have a compact representation of the relationship, because we represent source and node labels, source and node labels, yes, as maps. So you can leverage this feature by using the option relationship.nodes.map with the true, and we will see that our new data frame has a compact representation, because we have only 4 columns, rel type, and then we have source and target, which are internally mapped. So we have here a map with the name Anna Wachowski born, and the labels of the node and the internal idea as well. So if you need a compact representation, you can use this option. This is the same for the PySpark representation. So let's go ahead. And now we have the last way that we allow to read data from Neo4j, by providing your customer read-only query. So we support, as I said, only read-only queries, otherwise you will get an error, and you can define your Cypher query into the data source in this way, by setting the option query and as value your Cypher query. So here we are extracting all the person that have a role in the movie Unforgiven. And then we return the labels of the person as labels, the type of the relationship as a rel column, and the name of the person as a name column. So let's run it. We have our 3 columns as expected. So we have Clint Eastwood and Gene Hackman that are person and acted in Unforgiven, and Clint Eastwood also directed the film, and so on. Here we have the PySpark script. Okay, and the result is the same. Now I want to show you how we manage partitions. So as I said in the slide, you can leverage a partition by using the partitions option. And let's see what's happened if we execute the snippet. So basically, we are getting all the person that directed a movie. The total count for this part is 44. We defined 4 partitions. These are the 4 partitions, and each one has 11 records inside it. Okay, and then we printed the first 20. How we write data from Spark into Neo4j. So from a data frame into how we write basically a table into a graph structure. So we allow to write data into Neo4j in 3 ways that are exactly the same as we'll basically read the data from Neo4j, by defining labels in order to ingest nodes, by defining relationships in order to ingest path, and by providing your own custom Cypher query. So let's see the first one. So how we write nodes inside Neo4j, it's very simple. We have this cal snippet here. So given the band df, which is a data frame of 2 columns, ID and name, you need to invoke the data frame writer by calling the write method. Then you need to define the save mode. Then you need to call the data source and define the labels option, in this case person and musician, that are the labels that will be attached to each node, and then invoke the save method. So we support 2 Spark save modes for the node type. The save mode error if exists, that will build a cipher create query. On the other side, the save mode overwrite will be a cipher merge query, but in this case, you need to define another option in order to identify the merge key. The option is node.keys, as you can see in the Scala snippet, and you can also define a mapping by the column. So we have the ID column of the data frame that gets renamed inside the Neo4j, my new field name into Neo4j. Big fantasy of naming. So under the hood, we collect a batch of data frame rows and perform an unwind operation over it in order to ingest the data in the most optimized possible way. How we ingest relationships. So given the music df, which is a data frame of 3 columns, experience, name, and instrument, you need to you can ingest a relationship by defining these options. The relationship is the relationship type about the path. Then we have the save strategy, which is keys or native. Native is for data frames that are extracted from Neo4j. So in that case, we know the data frame structure and we can use it in order to automatically ingest the data. We are using it the most complex way. Then you can define the save mode for the source and the target node. In this case, we have 3 options: error if exist and overwrite as the insert of labels, but we also support another save mode that we call the match, that basically matches the node if you don't need to ingest the node as well during the process. Then the labels attached to the source and the target node, and eventually the node keys. So for the save mode of the relationships, here we support append that will build a cipher create query for the relationship, and overwrite that will build a cipher match query. Under the hood, also here we collect a batch of data frame rows, and we perform an unwind operation over it. So now let's go to the third ingestion mode, which is the one with the cipher query that allows you to transform any data frame into any arbitrary graph structure inside Neo4j. So it's very simple to leverage this feature. You can simply define the option query and then your cipher query. As you can see here, highlighted in red, we leverage an event property. The event property is, in fact, the data frame row that is transformed into map, so you can access to each data frame row by typing dot and then the name of the column. In this case, we have 2 columns, name and surname, and we access to them by event.name and event.surname. So under the hood, also here we collect a batch of data frame rows and perform an on-wind operation. So the full query will be a on-wind batch as event, and then your cipher, the concatenation of your cipher query. So there are important things to check while you are ingest data inside Neo4j, because getting good performances is a fine-tuning process, and there are several things that you should consider. So the first is partitioning. The source data frame can have a lot of partitions, and a high number of partitions can overrun the database because we open one connection for each partition. On the other side, have just one partition can lead to bad performance. So it's something that you need to balance depending on your configuration. The batch sizing, as I said, for each ingestion mode, we collect a batch of data frame rows. You can tune the number of the rows that we batch by using the batch.size option. And also this is highly dependent of your Neo4j configuration. And the third is that node keys are important because you need to define them accordingly to indexes and constraints that are defined in your database, because otherwise you can have bad performance or also double node creations if you don't define any constraints on the node keys. So let's go to the demo. Now we have this notebook here from Spark Data Frame into Neo4j. Okay, we will leverage an important feature introduced in Neo4j 4.0, which is the multi-tenancy. Here we define a new database. With Neo4j 4.0, you can define multiple databases inside the same physical Neo4j instance, while with version prior to 4.0, 3.5 for instance, you need to have one physical instance per database. So let's create our fresh database. Just run count query to be sure that is empty. Okay, the count is 0. So now let's write our nodes. So we have here the band data frame, which is composed by just one column. And you can define also the target database with the multi-tenancy feature by using the option database here. Then we have the connection option and the node label. So it's quite similar to how we read the data via data source. So let's run it. Okay, the data should be ingested. Now let's query Neo4j, and we have our three nodes. So we have the name, the label. Don't be scared. This is just a visualization problem of Zeppelin that shows only the first label here. But we are sure that we created the nodes with both of labels because we queried for both of them. So they are correctly ingested. Now let's create a constraint to a musician by asserting that the name is unique. Okay. And now let's try again to ingest the same data. So we use the save mode error if exists, which means that under the hood we basically do a create statement. So sorry. As we expected, the job failed, and if we scroll down, we will see why, because the node with the name Alex Lifeson already exists. So as we expected, it's working. So now let's update our nodes via the merge operation. we can leverage a cipher merge operation by using the overwrite save mode here. But as I said, we need also to define the merge key. And in this case is the name of the musician. So let's run the script and let's see the new field inside the Neo4j. We have the city as we expected. Now let's write our relationships. So we have a data frame composed by 3 columns: experience, name, and instrument. We want to create a relationship place, and for the save mode strategy, we use the keys. And for the source save node, we use error if exist. The label is musician, and the keys for the source node is name. On the other side, for the target node, we use overwrite as a save mode, for labels instrument, and we rename on Neo4j the instrument column as a property name. Okay, so let's run the script. Okay, and now let's go into the database to check what we insert. So we have 2 instruments in brown, as we expected, because we have drums and guitar. And we have 3 musicians. So if we click on them here on the bottom left, we can see that the field has been renamed for the instrument name as we expected. So now let's try to create to ingest the data via a Cypher query. So it's very simple. Now we create a data frame of 10 rows and of 3 columns: name, surname, and age. The create query is quite simple because we are basically creating a person, which is also a customer, and we define the full name property, which is the concatenation of name and surname, and we scale 10 years from the age. So let's run the script and let's check what we have inside Neo4j. As you can see here, we have 2 fields as we expected, and the full name is a concatenation of name and surname. Okay, now let's go through the through the third demo, which is about build a graph data pipeline with Spark and Neo4j. In order to do that, we will use the Chicago Crime dataset, which is a widely used dataset in data science. In order to have it, to download it, you can just run this paragraph. I did it before the presentation in order to save some time. So I already have it in my hard disk, and now we can load the CSV as a data frame with this script. So the data frame, we have our crime data frame, which is basically the CSV file. So let's print the schema. We have a ton of columns, but I want you to focus on the date, which is a string. All the fields are strings because they came from a CSV, so it's a default type, but in particular this one, because now we will apply some transformation over the crime data frame. In particular, we will transform the date into a timestamp, and we add 2 more fields: the day, which is a simple date without the time information, and the point, which is a concatenation between latitude and longitude. So let's create our data frame and let's print our schema in order to highlight the differences. So as you can see here, the date is a timestamp now, while here was a string, and we have the two new fields, day, which is a date, and the point, which is a string. So let's show our data frame as a table. Okay, we have the date, and if we scroll to right, we have the day and the point. Let's count the data set in order to understand how many records we are deal with. So we have 1000 records in our data frame. Now let's create our new database called crimes. And what is the goal of this graph data pipeline? So we want to transform our CSV into the graph structure that you see here into the paragraph. So we want to create 4 nodes: crime, beat, which is the police district, crime type, which is the primary type of the crime, and crime day, which is the day of the crime. And 3 relationships, sorry, between these 4 nodes. So we have one relationship on date that starts from a crime and ends to a crime day. Then we have the on beat relationship that starts from a beat and ends on a crime, and is type that starts from a crime and ends in a crime type. So now let's create our 3 constraints over the dataset. So we assert that the bit property on the bit node is unique. For the crime, we assert that the ID is unique. And for the crime day, we assert that the day is unique. Okay, just to be sure, let's run a count over the data set, but it's empty because it's freshly created. So we have our extended crime data frame, which is the one that I showed you as a table here. And we select only the bit column. And now we will ingest it inside Neo4j as nodes. So because we attach the label bit, and we define the node key bit, because we use the safe mode overwrite, because a bit can be repeated over records, and we don't want duplications. So let's see how many bits we ingested. 2056. Okay, so we started from 1000 records, and we ingested 256 bits. Now let's create our crime. Our crime is composed by these 4 fields: ID, description, case number, and point. And we use error if exists, because we are sure that we don't have duplication, because each row inside our dataset is a crime. Now we should find 1000 exactly. Now we insert the primary type, the crime type. So we select only the primary type. And also we use the overwrite because there are duplications. In fact, we have 22 crime types. Now we want to ingest the day. And now let's check how many crime day we have, only 2. And now let's go to ingest our relationships. So we want to ingest the relationship on bit that starts from a bit ends to a crime. And let's check how many bits we ingested, 1000, I guess. Yes. Now let's ingest the isType relationship. And let's check how many of them we ingested. Also here 1000. And now let's ingest the on-date relationship. But now I want to show that we can also attach properties to the relationship by using the option relationship properties. Here we define the list, the comma-separated list of properties of the data frame that we want to attach to the relationship. In this case, I want to attach to the relationship only the date, which is the date with the time information. Okay, let's check how many on-date relationship we ingested, 1000 also here. So now I want to show you, let me clear the output. I want to show you that the properties are managed correctly. Here we use the two epoch procedures in order to extract the class type of the properties inside the database. So we are basically extracting the day from the crime day and the date from the on-date relationship. And we have that the day is local date and the date type with the time information is the is assumed date time. So now let's query the graph directly from Neo4j just to see our structure in action. So we have here our crime day, we have the crime and the crime type as well. With this demo, the presentation ended. So just to wrap up what we saw, we saw how to leverage the data source API in order to ingest the data and ingest the data from Spark into Neo4j, and how to extract the data from Neo4j into Spark. We saw how we can handle the partitions, and we talk about some important concept while you are trying to ingest data into Neo4j in order to don't go through bad performances. So thank you for being here. Stay safe.